On this Ram 1500 Classic with the 5.7 Hemi P0340 is for the camshaft position sensor circuit on bank 1, sensor 1. In plain language, the PCM may be seeing crankshaft position information, but losing the camshaft position signal it needs for synchronization. The truck may still start, but it can have a delayed start while the PCM sorts out engine position, and the MIL can come on. The broad fault areas are electrical supply, signal and ground circuits, connector quality, sensor mounting or target wheel issues, oil-related cam facer effects, the cam sensor itself, and in the end of the diagnostic path, the PCM. Start with the basic system checks, then keep this diagnosis structured. This code is not a parts call until the circuit and mechanical checks point you there. The monitor runs continuously when battery voltage is above approximately 11.0 volts with the engine cranking or running. The diagnostic formula is simple. During cranking, if at least 2.5 seconds have elapsed with a crankshaft position sensor signal present but no camshaft position sensor signal, the code can set. With the engine running, if the camshaft position sensor signal is lost for at least 0.15 seconds while the crankshaft signal is still present, the code can also set. Treat those as the operating conditions to reproduce when you are confirming the fault and verifying the repair. First, check for any applicable bulletins for this issue. If one applies, perform that repair path, clear the code, and verify the repair. If no bulletin applies, look at the recorded codes. If any 5-volt reference codes are active or pending, diagnose those first before chasing P0340. Next, with the ignition off, check engine oil level and condition. Low oil, dirty or aerated oil, deteriorated oil, incorrect viscosity, oil pressure out of specification, or an incorrect oil filter can affect cam facer operation and lead you into the wrong diagnosis. If an oil issue is found, repair it as needed. If the level was low, top it off to the proper specification, start the engine, let it idle for 2-3 minutes, then turn the engine off, key on, clear the code, and drive the vehicle to verify. If P0340 stays gone, the repair is complete. If it comes back, continue the diagnostic path. With the ignition on, read and record the current codes and the captured operating conditions. Then start the engine, or crank it for at least 10 seconds and read the codes again. If P0340 is active or pending at that point, move into the electrical circuit checks. If it is not active or pending, treat it like an intermittent loss of signal and go after connections, mounting, and the sensor-to-target relationship first. For the intermittent path, turn the ignition off. Disconnect the harness connectors at the PCM and the cam sensor. Inspect for chafed or rubbed wiring, pushed-out terminals, bent terminals at the PCM and cam sensor, water in connector cavities, and corrosion at connector or component terminals. Also inspect the cam sensor mounting area for debris, damage, or a loose sensor. Remove the cam sensor and inspect the end of the sensor for damage or debris. Rotate the engine, and if possible, inspect the target wheel for damage. Reinstall the cam sensor correctly and tighten it to the proper specification. If you find a problem here, make the appropriate repair and verify the repair. If you do not find a problem, check the vehicle history for cam sensor-related faults within the past 90 days. If the vehicle has been in for a cam sensor fault in that window, replace the cam sensor using the proper replacement procedure. Perform the cam/crank relearn with the scan tool and verify the repair. If there is no such history, reconnect the harness connectors, clear the code, and verify it does not return. In that case, the likely cause was a poor connection disturbed during inspection. If the code is active or pending, turn the ignition off and disconnect the CMP sensor harness connector. Turn the ignition on. Measure voltage between the F856 5-volt supply circuit and the K900 ground circuit at the CMP sensor connector. You are looking for between 4, 8 and 5.2 volts. If that voltage is correct, measure the K44 CMP signal circuit at the CMP sensor connector. That circuit should also be between 4, 8 and 5.2 volts. If both readings are in range, turn the ignition off, disconnect the PCM-C2 connector and check for continuity between F856 5-volt supply and K44 CMP signal at the CMP sensor connector. If there is continuity, repair the F856 circuit for a short to the K44 signal circuit, then verify the repair. If there is no continuity, move to the sensor mounting and target wheel inspection. With the battery ground cable disconnected, remove the CMP sensor. Inspect the sensor mounting location for damage and foreign material. Rotate the engine and, if possible, inspect the target wheel for damage. If you find mounting damage, debris, or target wheel damage, repair the mounting issue, or repair or replace the tone wheel or pulse ring as needed. Anytime repairs or replacements are made to the CMP sensor, CKP sensor, flywheel, valvetrain, timing chain, or gears, perform the cam/crank relearn with the scan tool before final verification. If the mounting area and target wheel are okay, inspect the wiring and connectors between the camshaft position sensor and the PCM. Look for chafed, pierced, pinched, or partially broken wires, and for broken, bent, pushed out, or corroded terminals. Then install a new camshaft position sensor, perform the cam/crank relearn, clear the code, and start the engine or crank it for 10 seconds. If the code does not return, the repair is complete. If it does return, continue to the full connector integrity check. Disconnect all PCM connectors, related inline connectors if equipped, and related component connectors. Inspect the harness and component connectors and all male and female terminals for proper installation, damaged connector locks, corrosion, water intrusion, weather seal damage if equipped, bent terminals, overheated terminals from poor connection, terminals pushed back into the cavity, spread terminals, and proper terminal tension. Repair anything found. Reconnect everything fully and make sure the locks are engaged. Clear the code, then test drive or operate the vehicle under the monitor conditions and read the codes again. If P0340 returns after that connector integrity check, replace and program the PCM using the proper procedure, then verify the repair. If it does not return, repair the poor connection conditions found and verify the repair. If the F856 5-volt supply check was not between 4, 8 and 5, 2 volts, stay on that circuit. Measure voltage on F856 at the CMP sensor connector. If it is above 5, 2 volts, repair the 5-volt supply circuit for a short to voltage and verify the repair. If it is not above 5, 2 volts, turn the ignition off, disconnect PCM-C2, and check continuity between ground and F856. Continuity there means repair F856 for a short to ground. If that is clean, check continuity between F856 and K900 sensor ground. Continuity there means repair F856 for a short to the sensor ground circuit. Before the next resistance checks, do not probe the PCM harness connectors. Probing those terminals can damage them and create a poor terminal-to-pin connection. Use the GPEC Diagnostic 10436 adapter. Measure F856 resistance between the CMP sensor connector and the adapter. It should be below 3.0 ohms. If it is not, repair F856 for an open circuit or high resistance. Then measure K900 sensor ground resistance between the CMP sensor connector and the adapter. It should also be below 3.0 ohms. If it is not, repair K900 for an open circuit or high resistance. If both circuits pass, continue to the final connector integrity check. If the K44 CMP signal circuit was not between 4, 8 and 5, 2 volts, turn the ignition off, disconnect PCM-C2, turn the ignition on, and measure voltage on K44 at the CMP sensor connector. If any voltage is present, repair K44 for a short to voltage and verify the repair. If no voltage is present, turn the ignition off and check continuity between ground and K44. Continuity there means repair K44 for a short to ground. If that is clean, check continuity between K44 and K900 sensor ground. Continuity there means repair K44 for a short to the sensor ground circuit. Again, Use the GPEC Diagnostic 10436 adapter for the PCM side resistance checks. Measure K44 resistance between the CMP sensor connector and the adapter. It should be below 3.0 ohms. If it is not, repair K44 for an open circuit or high resistance. Then measure K900 sensor ground resistance between the CMP sensor connector and the adapter. It should be below 3.0 ohms. If it is not, repair K900 for an open circuit or high resistance. If the signal and ground circuit checks pass, disconnect the battery ground cable and remove the CMP sensor. Inspect the sensor mounting location for damage and foreign material. Rotate the engine and, if possible, inspect the target wheel for damage. If there is a mounting issue or target wheel damage, repair the mounting issue, or repair or replace the tone wheel or pulse ring as needed. Then perform the cam/crank relearn and verify the repair. If no problem is found, inspect the wiring and connectors between the CMP sensor and the PCM for chafed, pierced, pinched or partially broken wires and for broken, bent, pushed out or corroded terminals. Then replace the camshaft position sensor, clear the code and start the engine or crank it for 10 seconds. If P0340 does not return, the repair is complete. If it does return, move to the final connector integrity check. For the final check, disconnect all PCM connectors, related inline connectors if equipped, and related component connectors. Inspect connector installation, locks, corrosion, water intrusion, seals if equipped, bent terminals, overheating from poor connection, push-back terminals, spread terminals, and terminal tension. Repair anything found, reconnect all connectors fully, and make sure the locks are engaged. Clear the code. Then test drive or operate the vehicle under the monitor conditions and read the codes again. If P0340 returns after this point, replace and program the PCM using the proper procedure and verify the repair. If P0340 does not return, the poor connection repair is the fix. The takeaway is to prove the supply, signal, ground, connector integrity, and sensor-to-target relationship before condemning a major component. For more diagnostic training, visit stepdiagnostics.com.